This is a modified version of the periodic table. You'll notice that helium has been brought over to be next to hydrogen. You'll also notice that we have an orange, a blue, a green, and a purple section of the periodic table. Now again, with the exception of helium being moved over to the left, this is your standard periodic table. Now the reason it's been brought over here is so that we can talk about the four quantum numbers. The four quantum numbers are N, L, ML, and MS. The first quantum number, N, is for the energy level. Now oftentimes it will coordinate with the row or period on the periodic table. The L value is going to tell us specifically which orbital type we're in, the S, the P, the D, or the F. Now the reason for these letters will come up later on, but really we're just stuck with them. So the S section is the first two columns, the P section is the last six columns, the D section is the middle transitional metals where we've got 10 columns, and the inner transitional metals, the 14 columns at the bottom, will make up the F section. The third number is the ML. This tells us the specific orbital that we're in within a type. With the S, we have one orbital. With the P, we'll have 3. With the D, we'll have 5. And with the F, we'll have 7. The final number is going to be labeled with MS. The MS tells us the spin of the electron. 1 out of 2 will spin upward, 1 out of 2 will spin downward, or clockwise and counterclockwise. This first section shows the N value. The N value is the energy level. The N will also indicate the number of sublevels that are allowed. So you can see that the first energy level only has the S. The second energy level has two sections, the S and the P. The third energy level has the S, the P, and the D. The fourth energy level has the S, the P, the D, and the F. Now the fifth energy level should have 5, but we don't have enough elements for it. So it cuts off after the F. So S, P, D, and F. The sixth energy level technically would be allowed to have 6 different sections, but we only have 3 because of our limited periodic table. And the same sort of thing goes for the 7th energy level, where we only experience 2 sections rather than the 7 that would be allowed or permitted. The next section is the sublevel. The L value is the sublevel. Now, the sublevel is allowed to be at most, for a value, n minus 1. In the first energy level being 1, 1 minus 1 would be 0. And so the S block, the S section, is going to be listed or related to 0. The P section shows up in the second energy level, and 2 minus 1 is 1, so the P section gets labeled with a 1. The D section with a 2, the F section with a 3, so on and so forth as we have additional energy levels, and therefore additional sublevels allowed. The next section is going to show us the ML, or the specific orbital within a sublevel. So, if you look at the orange section, nothing has changed. There's only one orbital in the S orbital type, and therefore we'll have our upspin followed by our downspin, or 2 columns of elements. One for the upspin electron and one for the downspin electron. Now the ML value is allowed to be negative L through positive L. Negative 0 through positive 0 leaves us with only one number on the number line, and that number is 0. With the P section, P had an L value of 1, so negative 1 through positive 1 will give us 3 orbitals. You'll notice that boron is next to oxygen's column, carbon is next to fluorine's column, and nitrogen is next to neon's column. This is because we fill all of our upspin arrows first before filling our downspin arrows. So while the periodic table looks out of sorts, it's on purpose. The same thing happens in the D section and the F section. where we'll get -2 through +2 for the d section, and -3 through the +3 for the f section. Now, the number of orbitals for a specific type is going to be 2l plus 1. 2 times 0 plus 1 is 1 orbital. 2 times 1 is 2, plus 1 is 3 for the p section. 2 times 2 is 4, plus 1, giving us 5 for the d section. And 2 times 3 plus 1 gives us 7 for the f section. The final number tells us the specific upspin. Now, in the last sheet, I pointed out that the columns were put next to each other in an awkward fashion. This was because we'll fill all of our upspins, or clockwise spins, followed by our downspins, or counterclockwise spins. So, the first half of each block, the S, the P, the D block, are going to be our positive 1/2, or 1 out of 2 spinning in an upward or clockwise direction. And the second half of each block is going to be our downspin, or negative 1/2, negative 1 out of 2. 1 out of 2 electrons spinning in the downward or counterclockwise direction. Now, the quantum address is shown so that we can have a pattern that is unlimited. No matter how big our periodic table is or becomes, it should last and continue, unless we find something fundamentally wrong with our current model of understanding. So, we can go ahead and apply these rules for these addresses to a series of questions. Here they go. For a principal quantum number n equal to 7, is it possible for L to be equal to 7? Since L is allowed to be at most n minus 1, 7 minus 1 is 6. 6 would be our max. 7 is not allowed. Next, what is the L quantum number for an f orbital? Now, the S, the P, the D, the F are the ones that we have on our current periodic table. Any additional or future orbitals would have to go alphabetically, skipping over S, P, D, and F. Now, since S is associated with 0, and P with 1, and D with 2, and F with 3, this pattern would continue. Now, since it asked about the F orbital, F is equal to 3. Next one. What is the correct representation for an orbital which has an n value of 7 and an L value of 0? We always list the energy level when we represent these things in our electron configurations. So the 7 will show. A 0L will be coordinated with an S, so 7S. Next question. For the quantum number L equal to 4, is an ML value of 0 permitted? Absolutely. ML is allowed to be negative L through positive L. On a number line, 0 would occur, going between negative 4 and positive 4. For a principal quantum number n equal to 3, what is the total electron capacity of that level? Well, to figure out how many orbitals are allowed, we would do energy level, or n, squared. Since each orbital is allowed to hold 2 electrons, we'll simply double it. So 2n squared. Since the n here is 3, we'll do 2n squared, or 2 times 9, for a total of 18. Is the 6p orbital permitted? Yes. Once an orbital type is established, it will be permitted for every future energy level. The p comes up in the second energy level. 2p is the first p orbital section allowed. Therefore, it will be allowed for all future energy levels, even those that are just currently theoretical. For a principal quantum number n equal to 1, what is the total number of orbitals permitted? The total number of orbitals is always going to be n squared. 1 squared is still 1. This energy level only has the s orbital type, and the s orbital type only has one orbital. For the quantum number L equal to 1, how many orbitals of that type are permitted? Well, ml will give us a specific orbital. 2l plus 1 gives us the total number of orbitals that we would have to have for the ml. So 2 times 1 plus 1 is 3. Alternatively, we could have listed them all as -1, 0, and 1, and simply gone negative L through positive L and figured it out that way. What is the L quantum number for a k orbital? All right, S was equal to 0, P to 1, D to 2, F to 3, and then we would continue with G to 4, H to 5, I to 6, J to 7, and K to 8. So we're looking for a quantum number of 8 for our L value if we're looking for a k orbital. For a principal quantum number n equal to 5, what is the largest value of L? The largest value of L is going to be n minus 1. So 5 minus 1 is 4. 4 will be the largest value. For the quantum number L equal to 4, is an ml value of -6 permitted? No. ml is allowed to be negative L through positive L. So our number line would consist of -4 through +4. -6 occurs nowhere on this number line and is therefore not permitted. For a principal quantum number n equal to 5, what is the total number of orbitals permitted? N squared is going to give us the total number of orbitals permitted. So 5 squared is going to give us 25 orbitals in that energy level.